Good morning, boys and girls. Last time we met, we did examples 1 to 3, and I'm proceeding today looking at example 4. And example 4 reads, f of x equal to x cubed plus px squared plus qx plus r has an x-intercept at 2, 0. And a point of inflection at 0, -8. A requires us to determine the values of P, Q, and R, showing all necessary calculations. And part B says sketch f of x, f dash of x, and f dash dash of x on the same system of axes, showing all intercepts with the axis as well as the coordinates of the stationary points and points of inflection. So let us attend to part A. Determine P, Q, R, showing all necessary calculations. What do we know? We are told that there is a point of inflection on the graph, and that point is coordinates 0, -8, which means we can substitute our -8 on f of x because that's the y value, and then 0 for wherever there is x. So our r will be equal to -8. We already have the value of r as -8. What else are we given? We are given that there is an x-intercept at 2, 0. So we can substitute 2 and 0 in here. There is 0 for f of x, and we now substitute 2 wherever there is x on the right hand side. And remember, our r is known, is -8. So we shall have that, which reduces to that, which then when we make q the subject, we end up with -2p is equal to q. What else do we know? We know that the point of inflection, at that point, the second derivative is always 0. At the point of inflection, the second derivative is always 0. So we shall start by deriving for the first time. We have that. Then for the second time, we have that. Then we are saying f dash dash of 0, because at this point here, it is 0 at the point of inflection, but we know f dash dash of 0 gives us 0 because x is 0. So we shall have our 2p equal to 0. So our p is 0. So we have our p as 0. We come back here where q was the subject. We substitute p. Q therefore is also 0. So what we established? We established that our p is equal to 0, our q is equal to 0, and our r is -8, which means our f of x is actually x cubed -8. And part B says sketch. We are sketching the graph of f of x. We know there is a point of inflection at 0, -8. We indicate it will pass through the point 2. But we also noted that there are no stationary points. We don't have a maximum turning point and a minimum turning point. The only point that we have here is a stationary point. And we must always remember there is a change in concavity as we move to the left of 0 and as we move to the right of 0. Here is concave up, here is concave down. So we can draw the graphs of f. That is what we have done. Now we want f dash. F dash, according to what we have, if we derive this, our f dash will be equal to 3x squared. So which means it will certainly pass through the origin. And then we can have a point 2, which gives us 12, because we substitute 2 here. We shall have 3 times 2 squared, which is equal to 12. That is why this point is 2 and 12. And if we find our f, we can now draw the graph, as we have seen, of f dash dash of x. We derive, and we shall have 6x. Again, at 2, our y will be equal to 12. So it means it passes through the same point that we identified for the f dash. And it also passes through the origin, because when we substitute a 0 here, y will also be 0. So we can draw our straight line. Then we have answered question 4 completely. Now we are moving on to question 5. And question 5 says, consider the function g of x, which is defined by x cubed plus ax squared plus bx plus a c, which passes through the origin. That's a key word for us. It's passing through the origin, which implies that we shall have a coordinate 0, 0. We can use that point. And has a tangent given by the equation y is equal to 24x minus 54 at x is equal to 3. So we can actually now move on to answer part A. Determine the values of A, B, and C, showing all necessary calculations. Let us now answer that question together. Now, what do we know? G of 0 is equal to 0. So C is 0, because I said it is passing through the origin. So G of 0, which is x value, is equal to 0. So C is 0. We already have our C. Then at x equal to 3, we can actually find the y coordinate, because the line, which is a tangent, is passing through one of the points that is on the function f of g of x. Therefore, we can substitute to get our y value corresponding to x is equal to 3, which when we simplify, we get 18. So there is a point 3 and 18. Then we can substitute this point back into g. When we do that, we have that. When we simplify, we end up with 9a plus 3b is equal to minus 9, which implies that b is actually defined by minus 3a minus 3b. Make that equation 1. We now need two equations, because there are two unknowns in this equation. How can we do that? If we differentiate, we shall get 3x squared plus 2ax plus a b. And what do we know? We know that g dash at 3 is equal to 24, because at that point on the function g, the gradient of the tangent is equal to the gradient of the graph. So we end up with 3 into 3 squared plus 2a times 3 plus a b is equal to 24, which when simplified gives us 6a plus b is equal to minus 3, equation 2. I'm not going to teach you on how to solve these two. I'm just passing through it. When you solve 1 and 2, you end up with your a equal to 0, b equal to minus 3, and your c equal to 0. Then we are moving on to part B. If a is equal to 0, b equal to minus 3, and c equal to 0, what did we get, by the way? Exactly the same values. A equal to 0, b equal to minus 3, and c equal to 0. And the question in part B, part 1 says, determine the values of A, B, C, showing all necessary calculations. Sorry, I repeated part A. I'm here at part B, part 1. Determine the equation of the tangent to G, which is parallel to the tangent at x equal to 3. We want to find the equation of a tangent to G, which is parallel to the tangent at x equal to 3. We already know the equation of the tangent at x equal to 3. It's y is equal to 24x minus 54. So we are going to use that concept to answer our question. First, parallel lines have got equal gradients that we all know. So it means our gradient for which is g dash of x, when we differentiate g of x, we get 3x squared minus 3. which must be equal to 24, which when we solve, we end up with x is equal to plus or minus 3. The 3 has already been used. We are now using x equal to minus 3. So g of minus 3, we have minus 18. So we have a point which is 3, negative, and minus 18. That point, we are going to use it. Remember, y minus y1 is equal to m into x minus x1. So we know the gradient of this tangent must be equal to the gradient of the given tangent, which is y is equal to 24x minus 54. So we substitute here. Y minus y1, which is minus 18, is equal to 24. X into x minus 3. And then we have our brackets. We simplify. We end up with the equation y is equal to 24x plus 54. This is the equation of the tangent at x equal to minus 3, which is parallel to the given tangent. Part 2. Part 2 says, determine and classify the stationary points of G, showing all necessary calculations. This question we have done over and over again. I'm simply going to rush through it. At stationary points, what do we know? The gradient is 0. So we end up with that. This gradient, that is the derivative of G, is equal to 0, which implies that our x is equal to plus or minus 1. So G dash of minus 1 is equal to 2. That's important for us. So G dash dash of minus 1 is minus 6, which is less than what? 0. So G is concave down, which implies that at minus 1, 2, we have a local maximum. Then G dash of 1 is equal to minus 2. And G dash dash of 1 is equal to 6, which is greater than 0. So G is concave up, which implies that at the point 1 minus 2, we have a local minimum turning point. Very, very important for us to, we have managed to classify and determine the stationary points as well. Then from there, we are doing part 3. Determine the points of inflection of G. Justify your answers. Well, in this question, we are talking G dash dash of x, because the x value is always given when we derive for the second time, and that is equal to 0. Then x is 0. We know that G is concave up. Already we know at x equal to 1, G is concave up, and concave down at x equal to minus 1. And our x equal to 0 is in between, which means there is a change in what? In concavity at 0, 0, and hence 0, 0 is a point of inflection. Then the last question says, sketch G showing the intercepts with the axis and the coordinates of the stationary points and points of inflection, showing all necessary calculations. Well, calculations are done already in all these questions. We were doing all the calculations. We already have our maximum turning point at minus 1, 2, which we said is concave down already. We can see it here. So this is one of the turning points. And this graph has got a point of inflection at 0, 0, which we identified here, 0, 0. And here, what do we have? We have a minimum turning point, which we also talked about here. At 1 minus 2, we have a minimum turning point, which is that. And now you need these two values, these other two values. You know how we deal with the cubic function. We use our synthetic division after we have used the factor theorem. So apply your factor theorem, and then you end up with a quadratic, which you then factorize as normal as we normally do. You may be, in this case, because it's not an integer, you may be forced to use the quadratic formula. And then after that, we will do the following. Classwork, exercise 13, numbers 6 to 8. Numbers 6 to 8. And your homework is exercise 13, numbers 9 and 10 only. I thank you so much.